What about the trigonometric terms? Here I've got a graph of cosine and a graph of sine, and I want to figure out what's the derivative of sine and what's the derivative of cosine. Now in this video, I'm not going to go through the formal geometric proof of these derivatives, but I want to illustrate why my answers are going to be reasonable. So let's go and look at sine of x and try to take the derivative of sine first. And let me focus at the value of 0. So here is a tangent line to sine of x at the value of x equal to 0. And this tangent line, it looks like it's got this nice slope here of approximately 1-ish. But then cosine has the value of 1 at 0. So in other words, it kind of looks like the tangent line of sine at 0 and the function value of cosine are going to be the same thing. All right, let's step along. What about at this point? Okay, so now we've sort of flattened down a little bit. So if we were going to say that the original slope was 1, this is a little bit less than 1 here for sine. But I know what cosine of pi over 4 is. Cosine of pi over 4, I could draw the standard triangle. It's 1 divided by root 2. A number a little bit less than 1. So the slope has gone down a little bit, and the cosine has also gone down a little bit. Likewise at the top here. Okay, this one I can do easily. This is exactly horizontal. So in other words, the derivative of sine is 0 at this value of pi over 2, but cosine of pi over 2 is equal to 0. Final one here, the slope started at 0, but now as we go beyond pi over 2, it's becoming negative. The slope is negative, but likewise, cosine, it goes down to 0 and then becomes as negative as well. So what I'm sort of getting the sense of is the derivative of sine and the values of cosine seem to match a lot. So I'm going to claim here that indeed the derivative of sine is equal to cosine. And by the way, you could do the same kind of analysis to go for what happens with cosine, and you get the derivative of cosine is equal to negative the value of sine. For example, if I look at the derivative of cosine at 0, it's horizontal. This is the same thing as the value of minus sine of 0. It's minus 0, which is 0. Now that I have these two established, the sine and the cosine, I can do a whole bunch of the other derivatives of trigonometric functions. So how about we do this one? I'm going to take the derivative of tangent of x. Now, tangent is sine divided by cosine. So in other words, what I'm saying is I want to do the derivative of sine of x divided out by cosine of x. And then this is a quotient of two functions, the sine divided out by the cosine, so I can use the quotient rule. So let's see if we can remember how that works. Okay, so first of all, it's the derivative of the top, so derivative of sine is cosine, multiplied by the bottom, so it was f prime g, so multiplied by cosine, so I'm actually going to come up here and put a cos squared in, because it's cosine times cosine. Then I subtract, and what do? I put in the first thing, so that was going to be sine of x, so the f, no derivative there. And now I'm taking the derivative of the bottom. But the derivative of the bottom is derivative of cosine is minus sine. So there was a minus here, but I'm going to turn it into a plus because I'm taking one more. And then it's minus sine, I've got another one here, so I'm going to put it as sine squared of x. So that's the top. And then all of this is going to be divided by the denominator, the cosine squared. So all this divided by cosine squared of x. So in other words, we've gotten a decent way, purely on our knowledge that tangent is defined to be sine over cosine, and then we apply the quotient rule. Now, there's one identity that's very important. Cos squared plus sine squared is equal to the value of 1. So the cos squared plus sine squared, I can just replace this with 1, and then it's 1 divided by cos squared of x. And 1 over cos is the definition of secant. So 1 over cos squared is the definition of secant squared. So this is going to be equal to secant squared of x. And then I could go through if I wanted. I've done the derivative of tan and got secant squared. I could do derivative of cotangent, derivative of secant, the derivative of cosecant. All of these different things are fractions of the sines and the cosines. And so I could apply the quotient rule much the same way, use this same Pythagorean identity that cos squared plus sine squared is 1, and I can get a bunch of results. The full list looks something like this. It's sort of long and complicated if this is the first time you've seen it. I'll let you know that in calculus, we're going to be using these derivatives so often that you're basically going to end up memorizing this particular chart just because you're going to use them over and over and over again. But in truth, you only need to know the sine and cosine ones. And then all of the other ones, if you remember the definition, for example, that cotangent is cosine over sine, you just apply the quotient rule and you can get this formula on the test. But it's a good idea just to go ahead and memorize them just by practice and repetition of how many times we will use them.